In this lesson, we are going to learn how to represent points in a Cartesian coordinate system. So let's go to practice this idea with many examples. So this is the Cartesian coordinate system. It has a vertical axis and a horizontal axis. The horizontal axis is named as the x, and the vertical axis is named by the y. So we have 4 quadrants. You see here there is one quadrant. Here there is another quadrant. There is another quadrant here, and there is another quadrant. So this is the quadrant 1. This is the quadrant 2. This one. This is the quadrant 3. This one, and this is the quadrant 4. So we need to be sure where the point is that we are going there to represent, in what quadrant is. So let's go to erase all this, and we practice. So let's say that they give you a point, and the point have an x and a y, an horizontal information and a vertical information. So let's say that they say x is 3 and y is 2. Always the x comes first. The x is 3 and the y is 2. How we are going to represent this point on this Cartesian coordinate system? So in this way, if the x say 3, so you walk 3 steps in the x direction. So 1, 2, and 3. So you are here now. And now if the y is 2, you walk 2 steps going vertically, because the y-axis is a vertical axis. So 3.2 is the point that is obtained by walking 3 units in the x direction, 1, 2, and 3, and 2 units in the y direction, 1 and 2. So here is the point, here. So let's go to represent the point, is here. So let's go to represent the point 3 minus 2. So 3 minus 2, the second point, this one, is the point that is obtained by walking 3 units in the x direction. Remember, always the x comes first. And minus 2 units or steps in the y direction. Let's go to do it. 3 units in the x direction. 1, 2, and 3. And now it say minus 2 units in the y direction. Minus 2 units in the y direction. You go downwards. 1 and 2. So the point is exactly here. So the point 3 minus 2 is this point, and we can label like 3 minus 2. And the point 3, 2 is this point, and we can label as 3, 2. In doing in this way, we can plot many points. The point 3, 2 is in quadrant 1, while the point 3, minus 2 is in the quadrant 4. What is 3, 0? 3, 0 is walking 3 units in the x direction. Remember again, the x comes first, and later on walking 0 units, not up, not down, in the y direction, where it will be this point. Okay, let's go to do it. I walk 1, 2, and 3 units in the x direction. I don't move up, I don't move down. So 3, 0 is this point. This is the point 3, 0. And what is the point 3, minus 2? Well, 3, minus 2, we already obtained. And 0, 3, this point, what is? This point, it say, in the x direction, you don't walk. So you start here, you don't walk. and you go 3 units up. In the y direction, you go 3 units, 1, 2, and 3. So the point 0,3 is this one. 0,3 is this point. Let's go to represent now this point, minus 3,2. Minus 3,2 means that the x is minus 3 and the y is 2. So what it means? Walk in the x direction, minus 3 units. So plus 3 units will be going to the right. Minus 3 units, it will be going to the left. Minus 1, minus 2, minus 3. So you are now here in minus 3. And now you have to walk 2 units up. How you will walk 2 units up? You go from point minus 3, 2 units up. 2 units up will means that you are here. Minus 3,2 is this point. Minus 3, and you walk up 2 units. So in this way you can represent many points. Let's say minus 3, minus 3. Okay, you walk minus 3 units to the left, and later on you walk minus 3 units in the y direction. 1, 2, 3, downwards. So you are here. So the point minus 3, minus 3, the x and the y is this point. This is the point. Okay, and you can represent this point. So you can represent the point minus 25, 30. But here there is no minus 25. So you need to imagine and to make this shorter, or one trick is to change the size of the 1. So maybe you can check minus 10, minus 20, plus 10, plus 20, plus 30. Now the size of the step is being changed, and now you can represent minus 50, minus 60. Minus 25 is something like here. Minus 25, the x and the y. And 30, you change to 10, 20, 30. 30 would be here. So minus 25, 30 will be a point here. Okay, and what about to represent 4/3 and 5/3? How you will represent 4/3 and 5/3? Well, to do it in this way, you can represent 1/3 and say like this. You multiply by 3 the x's. So the 1 will be like this, will be here. This is the 1. So this is 1, and now the 2 will be here, the 2. So you rescale the x-axis. So the 1 will be here, the 2 will be here. You rescale by 3. Now, if the 1 is here, 1/3 is here. And 4/3 is going 4 times. 1, 2, 3, 4, 4/3. So 4/3 will be here. And the 5/3 for the y, because 1 is here, and this is 1/3. This is 2/3. This is 3/3. And this is 4/3. And this is 5/3. So you are here. 4/3, 5/3 is here. 4/3 is this one. 4/3 and 5/3 is here. So what you need to do to represent this is to change the scale that you are using. For example, let's go to do this. minus 0.75 minus 125, minus 0.25. So you need to represent the point a different way to make possible that you can find this point. Minus 0.75, if this is 1, 0 and 1, this is 0.5, and 0.5 if in the middle between 0.75 if in the middle between 0.5 and 1. So minus 0.75 is, let's go to do it bigger, bigger, bigger. So you divide this in 4 parts. And now here, 1, 2, 3, here is minus 0.75. So the problem says that you need to represent minus 0.75 minus 1.25. So minus 0.1 minus 125, you divide this in 4 parts. 1, 2, 3, and 4 parts. And this is minus 1.25. And the point will be here. Okay, this is a little bit more complicated than before, but the idea is the same. Located point. Minus 4,0. Where is minus 4,0? I will tell you here. Oh, minus 4,0. And which point is this one? The point A. Oh, I will tell you. What is the x? The x is minus 5. What is the y? The y is 2. So the point A is minus 5,2. What is the point B? What is this point B? The x is 0, and the y minus 4. Perfect. This is point B. And now let's go to represent the point. 0,2, quickly. 0,2, I see very, very fast. 0,2. The x is 0 and the y is 2, so 0,2 is here. 1,4. 1,4, the second point, is 1 unit to the x and 4 units to the left. It will be here. And what will be this point, the last point? Minus 4, minus 6 is walking minus 4 step to the left in the x direction. This is the x, this is the y. And walking minus 6 units in the y direction. So the point minus 4,6 is this point. Minus 4, minus 6. Okay. Now, for example, the point 5, minus 3. What is the point 5, minus 3? 5, minus 3 is this point. 5, 1, 2, 3, 4, 5 for the x, minus 3 to the y. So it's this point, 5, minus 3. In what quadrant is? Quadrant 4. Quadrant 4. So the quadrant 4 is the quadrant when x is positive and y is negative. So this is the characteristic of quadrant 4. For example, what is the point minus 8,4? Minus 8 is here. 4 is going up 4 units. So this is the point. So for this point, that is minus 8,4, he is on the quadrant 3. And for the quadrant 3, the x is negative and the y is positive. Okay, always this quadrant is filling with numbers where the x is negative and the y is positive. Okay, another one. Minus 2, minus 1. Well, you walk minus 2 in the x direction, so you are here. And now you walk in the y direction, minus 1. The x and the y. Minus 1, so you are here. So this is the point. The point is minus 2, 1 is minus 2, minus 1 is this point, minus 2, comma, minus 1. And in what quadrant is? In quadrant 3. And what is the characteristic of the quadrant 3? That the x is negative and the y is negative. So you are in quadrant 3. So when they give you a point when the two of them are negative, you know already that the quadrant is the quadrant 3. 0,7 is the point, this one, 0,7. And in what quadrant is? In quadrant 2 or in quadrant 3? Oh, it's on the axis, so it's in the middle. Okay. Well, and you do problem 5, you do problem 6, 7, 8, 10, and the lesson is done. Good luck.